Now we are diving into regularization and why it's essential for creating models that perform well not only on our training data but also on new unseen data. Let's take a look at the graph on the screen. It's a classic visualization of the bias variance trade-off showing how different errors contribute to the total error of machine learning models. On the x-axis, we have model complexity. As we know, move to the right, our model becomes more complex. On the y-axis, we have error. Higher up means more error. Notice the blue curve label and the bias square. Bias refers to the errors from overly simplistic models. High bias can cause the model to miss relevant relations between features and the target output. Thus, the bias typically decreases our model and it gets more complex. The green curve label, which is variance, represents error from too much complexity in the model. High variance can cause the model to model the random noise in the training data, which is overfitting. As model complexity increases, the variance goes up. The red curve is the total error, which is the sum of bias square and variance. The goal is to find the sweet spot where the total error is at its maximum. That is the point marked as optimal model complexity. Regularization is a technique we use to find its optimal point. It involves adding a penalty for complexity to the model's error term. This discourages the model from becoming overly complex and fitting the noise in the training data, which can lead to poor performance on the new data. In a sense, regularization helps to balance bias and variance. It pushes the total error down by finding the right level of complexity for the model, complex enough to capture the underlying patterns in the data, but not so complex that it gets distracted by the noise. So, this is a quick overview of regularization. And we will get, and also in regulation, we have two different techniques. One is L1, which is lasso, and L2, which is ridge. And also we have the third one, which is elastic net. And we use different regulation techniques for different machine learning projects. Thank you.